Hey guys, this is the third video, history of the periodic table. Before you get watching this, I want you guys to go into either Classroom or on the playlist on YouTube and actually watch the Mendeleev song first. Kind of give you a bit of a more background before we kind of dig deep in. So I would encourage you guys to go ahead and pause this video and then come back to it after you watch the song. So let's talk about chemical periodicity / the history of the periodic table. So the first guy to kind of start putting things together towards what our modern day periodic table looks like was a guy by the name of Dmitri Mendeleev. Hence, who told the elements where to go? Mendeleev. Make sure you know that. He's the first chemist, like I said, to arrange those newly found elements to form a usable manner. The elements arranged in his first one according to atomic mass. All right, so that resulted though in some gaps or periodic trends or intervals being out of order, which did not bode well when new elements came in specifically. So there were some gaps. He didn't know where everything quite was based on masses. So it wasn't perfect, but it was the beginning of our table that we use all the time. Fast forward a little while, a guy by the name of Henry Moseley in England, he used X-ray spectra to prove the existence of the proton. So up to this point, because of Rutherford's gold foil experiment, we knew that the proton existed, right? Some of those particles were deflected, saying that, hey, we knew the particles were positive, so if they're being deflected, that means there's some other positive charge in the nucleus. Moseley proved that the proton was there, and he actually began arranging the table by atomic number, which is what we use today. Which, if you remember, just as a quick review, that the atomic number is just the number of protons. Remember, if you change the number of protons, you change the element. So the modern periodic table is arranged by that. There's no more gaps because it goes based on protons, not by mass, which we know or should know. We have these things called isotopes, right, where they have different masses. We just had a test last week on that, or that was part of it, that they have different numbers of neutrons, so their masses are going to vary. But we don't want that. We want something that's nice and neat and organized, and that would be the proton, the atomic number. Okay, so it started taking shape. Let's kind of go through and talk about this thing called periodic law, because once we found out that, hey, we can base it on protons, these other things started coming along, and that's really important, where we're going to kind of go with the rest of our unit here. So periodic law just means that elements in the periodic table are what we call periodic functions, okay, of their atomic number. And we'll kind of dig into that a little bit as we go. Okay, as you move down a group or column, and we'll talk more about those in the next video, you add a principal energy level. So one principal energy level. You might see them referred to as PELs, principal energy levels. Basically, guys, if you're thinking about Bohr's model, every ring around the nucleus is a principal energy level. Okay, so as you go down a group, you gain another energy level. They're also called electron shells. So you'll hear both terms. Again, it's where the electrons reside, or part of where they reside. As we move across what's called a row or a period, again, we'll dig deeper into those shortly, you add a proton to the nucleus, and you add an electron to the valence shell. Remember, valence shell means outer shell. So as we go from left to right in a row on the periodic table, we're adding one more proton. Again, this should be obvious to us. We've done some already, so it shouldn't be anything groundbreaking here, just kind of putting it down on paper. One thing we got to remember as we go throughout and when we get into bonding in our next unit, the maximum number of valence electrons any element can have is 8. Therefore, any element that has 8 valence electrons marks the end of a row or period. Okay, make sure you really familiarize yourselves with periods and groups. That's what you'll see a lot. We're just kind of using the common pieces with rows and columns right now because it's so new to us. The next element will be the first of a new row, and we'll restart the pattern with 1 valence electron, which again, we already looked at that in the last video where you kind of saw that everyone in the group had the same one. So kind of think how Sunday marks the start of a new row on a calendar or restarts the weekly pattern. That's kind of like a good analogy to think about. Number 4, the number of valence electrons dictates the number of bonds. And again, we have a whole unit dedicated to that after this unit, taking things piece by piece here. So the valence electrons dictates the number of bonds that an element can form. The number of bonds that an element can form dictates that element's chemical properties. So one thing we're going to call groups by another name, and we'll kind of talk more about that when we get there in the next video, but those properties are really important. And again, it comes from those valence electrons, really the only ones we care about. Number 6, all the elements in the same column. Again, we're using that general term. You need to start knowing that, hey, column means group. They have the same number of valence electrons, which we've already seen. Therefore, elements in the same group, column or group tend to have similar chemical properties. So kind of an analogy for that is think of how you feel on every Monday or Friday, right? Everybody dreads Mondays, everybody likes Fridays. That pattern repeats itself in weekly periods. All right? So that's just kind of a brief intro, kind of the history of the periodic table. We will start talking about how the periodic table is arranged in the next video.